Hi, everyone. Uh, we'll just give like a minute for people to join. I see a bunch of folks joining, and then we can get started. Okay, it is 9:01. We'll get started. For people who are going to be joining a little later, we will have this recorded and available for you to like consume it later. It will be hosted on our site. Today, we are going to be talking about Kubernetes at the edge, but mostly in terms of like what are the pitfalls of deploying Kubernetes at the edge and what does it mean to deploy Kubernetes at the edge. We are going to look at it from a holistic manner and like see what are all the things that like you have to solve or account for before having a proper Kubernetes at the edge deployment that is both manageable but it also doesn't break the bank. Yeah. Get started. I am Raghu Vatte. I'm the field CTO and VP of product management at ZEDEDA. Been with ZEDEDA for almost 5 years, and prior to ZEDEDA, have a extensive experience in very large companies, networking companies, and also other startups. Before getting into the meat of today's discussion, it is a very good thing to like understand what edge is. Edge means a lot of different things for a lot of people. If you talk to cloud providers, then the cloud edge is the edge for them. If you talk to a telecom, then there is a telecom edge. And then obviously we have the data centers, we have the local data centers everywhere. What ZEDEDA started out and what we are going to be concentrating on today is the edge that is not a very common thing or like that has not been the area of concentration over the past decade or two, which is like the device edge, which are like embedded PLCs, smartphones, your Nest cameras, all of those things that are both in the consumer space, but also in the industrial space and also in various other verticals. That is like the base of the things, right? But then there is another layer below that, which is like people and things. That these are the entities that actually contribute a lot to edge, both in terms of the policies and the security that needs to be implemented, but also in terms of the user experience and what are the kind of things that are expected out of the edges. Then there is a gateway edge, which is the aggregation point where like you have all the embedded devices and also other processes are implemented. Think of them as like small devices, one or two devices, usually a singleton, like just a single device that is sitting out in the field and serving a purpose. Okay, these used to be a single purpose devices, but lately like they have evolved into things that can actually run multiple applications and where like there is a lot of optimization that can be done. And then just above that is the compute edge, where we are no longer talking about a small device, which is the form factor of an Intel NUC or a small Advantech Uno gateway. But we are talking about a pretty decent sized server, right? Like we are talking about a 1RU server, whether it is from HP, Dell, and other companies. But these have a little bit more requirements that are very similar to what you see in the data center, but at a much lower scale. Again, scale down, right? So you are talking about 1 to 3 to 5 of these servers, which are placed in areas that are not typical data center locations. And then they are supposed to be providing an outcome in that stack. Now, these can have like a variety of connectivity needs. They can have a variety of application outcomes that they are deployed for. And then they are also not placed in a similar situation, similar locations, like a data center, which has a physical security, which has like a good power, which has things that do not require these servers to be ruggedized and all of those kind of things, right? So when ZEDEDA started, we concentrated on the gateway edge and the compute edge, and we have been doing this for the past 5-6 years, and we have gotten a lot of traction in these areas. Now, our customers are pushing us both above into the local data centers, where they see that like there is a need for deploying applications and managing and orchestrating them. But also, on the other hand, they're also pushing us down into the device edges, where they also see that like, okay, if you can do the same thing with the gateway edge, can we do something similar with the device edge? Because the kind of outcomes that you would get by able to like optimize that level is like huge. So like we see that the edge that we started out with, which is the gateway and the compute edge, slowly increasing. But this is the area that I want to talk about today in terms of Kubernetes. Again, I have not talked about Kubernetes at all till now, but like that is what like we will be concentrating on. If you have any questions, please feel free to ask them in the chat, or like you can always reach out to us after the webinar, and like we can answer them offline too. Okay? So before we get into why are we talking about Kubernetes, just a very quick slide about like what is a need for even talking about Kubernetes towards the edge. What is the main driver for it, right? So we have seen that like over the past decade, I would say I would actually go back to like almost 2 decades, because IoT is a very big driver for all of this, but it has been done in different forms even before it was called IoT, where you had a bunch of devices, sensors connected, and we are trying to provide an outcome or achieve an outcome that is going to make the business proposition a lot better. Now, because of that, there is a lot of data that is being generated out in the field. And now that data has to be processed in one way or another, right? So now the first and the easiest way is to say that, okay, I'm going to like take that data, send it to a centralized location, whether it is your local data center or to a cloud, and then analyze the data there and provide inferences, provide outcomes from that data. Now, as the popularity, as the ubiquity of these devices, not just the IoTs, right, like every other thing increased, it is no longer practical to take all the data out to the edge, out to the cloud. Now, what is going to happen if you are not able to take the data all the way to the cloud? Then only other reasonable thing to do is to take those applications that are used in the cloud and then deploy them on as close to the source of the data as possible, so that now you are not sending the whole raw data stream all the way to the cloud, but like now you are doing a lot of processing out at the edge. And that processing might actually result in the outcomes at the edge, or that processing might result in filtering the data so that you are only sending the golden bits out to the cloud, so that like you can do the analysis and create the outcomes there. So now that is the trend that we have been seeing. This has grown. I mean, there are a lot of different variations of it. If I go on this track, like I can spend the whole 1 hour just talking about a lot of other things that we see or we have seen in the past 4 or 5 years. But the basic premise still stays the same. If you cannot take the data to the place where you are computing and making sure that like you are getting an outcome, then you are going to be taking the applications back to the edge. And that is what this talk is about. How do we take those applications back to the edge? And how do we actually do it in a manner that it is both practical, but more importantly, it is economical, and like it is going to make sure that it justifies the outcome and the investment that people want to do on the edge. If by doing this in a more practical and an optimized manner, we think that like we will be able to like enable the edge much quicker, much faster. And more importantly, there are a lot of other factors that come into the picture, both in terms of the skill and also the experience. And how do we make sure that like people who are really used to the cloud side of the picture now have a very similar experience when they are dealing with the edge too. Okay. So that is the first, that is the premise of having a Kubernetes at the edge. But people don't start out by saying that like, hey, I am going to, no one wakes up in the morning and says that, oh, how do I install Kubernetes at the edge? How do I manage it very optimally, and like making sure that there is a return of investment that is like on par with the kind of investments that we are doing. No one does that, right? Like it all starts with the outcomes. It all starts with the fact that like you want to achieve something, and the best way of achieving it is pointing you towards the edge. Okay. So now this is a slide that like I like, because it actually talks about the human element of this. There are a lot of people are thinking about modernizing. Hey, everyone you ask, like they're talking about, hey, how do I do digital transformation of like whatever I'm doing? Okay, you go and ask them, what does that actually mean? You get like 10 different answers, right? Everyone has a different way of describing the elephant. But at the end of the day, a lot of people do want to go towards that on the journey of modernizing their workloads, modernizing their outcomes, modernizing how they install and operate and all of these things. Now, that digital transformation is a very, very big factor in terms of like how we actually achieve or enable the edge. Now, when these architects that are sitting there in all of our companies are thinking about modernizing, one of the basic things, again, I say basic because it is not just about like one aspect, there are multiple aspects, but today we are going to be concentrating on one of these aspects, is how do I take a workload or a solution that I have implemented out on the edge. Now, it comes into two different forms. The first one is I have something that is already running on the edge, and I want to modernize it so that like I can make it more modular. More importantly, it is not just for the sake of making it modular, right? So that I can introduce new functionality in a way that it is more dynamic. I can actually increase the fidelity of this whole deployment. That is one thing. The second way is like, okay, I want to be able to deploy a lot of applications out in the field. I want to achieve an outcome and deploy that solution out in the field. And now I want to do it in a new age way rather than going down the path of a monolith. And this is where a lot of containerization comes into picture. Again, this is not new. This has been there for like 10 plus years in the field. It is really a mature technology, and it has a lot of community backing. So it is actually improving by the day. But what it also means is that these architects are given the task of like saying, you have this very large monolith that is the bread and butter of our operations. Now, I want the ability to peel off each single layer and then make it another microservice, make it another container. And then towards the end, like I will end up with a fully modern architecture, or I start with a fully modern architecture. More often than not, what we see is like it is both of them. So like we need to be able to like provide a way to make sure that like we have both the things available at the same time. And that again leads back to, okay, I do that, but now we are talking about edge, which has a variety of different constraints, and we are going to talk about them in the next slide. But with those constraints, how do I orchestrate it? How do I manage it? It's great to be able to do this in a lab, But like if I am going to be doing it in the field, all of a sudden my scale goes from 10 locations to 10,000 locations. And do I have to reinvent the whole wheel when I do 10,000 locations versus 10 locations, right? And it's also the people and the processes that are very important in this, because if any one of us who has been like dealing with the cloud, I deploy an application on the cloud. I don't really care about like who is managing everything underneath that. I expect some things to happen there. There are table stakes that are already set, and like I'm just using everything on top of it. So that is the experience that people are used to. Now, when it comes to the edge, it's completely different. And we have to like bring the experience on the edge as close to the cloud so that you can take the skills that are already developed in an organization. You can reuse the investments that you have done in like creating all that infrastructure in the cloud and the skill set in the cloud and take it back into the edge. Now, again, there are 10 different ways of doing it. One of them is Kubernetes. Kubernetes is definitely something that has been invested in like quite heavily. There are different ways of like orchestrating containers or orchestrating workloads across different platforms. But Kubernetes has a lot of community backing and also is improving by the day. So this is a very natural way for the people to think in terms of like, okay, why am I going to the Kubernetes on the edge? Because there is so much development that is happening. There is a lot of things that are happening in the Kubernetes world that can like actually apply to the workloads that I'm doing. Now, there are problems in doing that. There are large hurdles that you need to cross. But if you are able to cross it, then you can take all the investment that you have done on the data centers and in the cloud and bring them back to the edge. Okay. So this is, again, like over and over again, like in the last 4 or 5 years, talking to architects at very, very large companies and also small companies and startups. This is the thing that we have been seeing. This is a trend, definitely. And it's very important to understand this trend because it's not about Kubernetes. It is not about containers. It's always about the outcomes and like how do you provide it. And those are the things that make the best sense in terms of what is it that like you are actually providing to the end user. What you're providing to the end user is a future proofing. So if I am going to like embark on a journey, again, like edge journeys are like long. It is not fail fast and fail quickly because like failing fast might not be just a security aspect, but it can be a safety aspect too. So people do not really understand coming from an IT background. So there is very little wiggle room in terms of failing. So there is a lot of conservative thinking when it comes to edge. And rightfully so. You don't want people to be failing fast when you are doing an oil and gas drilling. Okay, people are going to get hurt. You do not want people to fail fast when you take your car to a dealership for a service, because if something goes wrong, the worst is like the best thing is like you'll need an Uber to go back to your house, but the worst thing is like you don't have a car for a very, very long time. Those are the kind of things that are very critical. So the constraints that people work around in terms of Kubernetes or like outcomes in the edge are different. I'm going to spend a couple of minutes on this slide before getting into the next one. Just talking about what are the kind of a variety of problems that like you have to solve first before thinking about Kubernetes, right? So first thing is like, because these edges demand that like your outcomes have to be achieved in geographically disparate areas. They have to be done where there is no real IT skill set available to physically touch the box all the time. So a remote lifecycle management of everything is really mandatory to solve anything that is edge related. Definitely Edge Kubernetes also. So you need to be able to solve the hardware management. You need to be able to solve the application management lifecycle. You need to be able to solve the security management lifecycle, right? Like all of these things have to be done. Now, edge also means that like there is a diversity of IO, there is a diversity of hardware, there's a diversity of OS. You are talking about things that are spanning from Raspberry Pis or like smaller devices than that, all the way to like 3 or 5 node 1RU clusters, right? That do like things right all the way to like storage clustering on top of these things. And on top of that, think of every single place having a different type of an IO. It's usually not every single place, but every single deployment is a very fair thing. Some deployments might have FPGAs, some deployments might have GPUs, the others might have a different type of Ethernet requirements, or an LTE or a satellite requirements. And add to this things like USBs and display ports, audio ports. All of these things are things that we see daily in a daily basis, and they are really hard to solve in a very generic manner, right? I talked about like LTE, satellite, and all of these things. LTE satellite, by the nature of the connectivity itself, makes it very unpredictable. You don't want your outcome to be different just because it's raining outside. It has to be like the same thing, whether you are in a connected environment or an unpredictable or a degraded connectivity environment. But we also have to think about like what happens if for reasons that are either natural or because they are implied or imposed because of a corporate policy, you are working inside an air-gapped environment. Now, you should still be able to solve it. And you can have 10,000 of these air-gapped environments, and you should still be able to solve for outcomes on those things. Obviously, we talked about the modernization of legacy workloads, which means that like not only should you be able to offer all the new age things like containers, runtimes with Kubernetes or others, but you should also be able to run your Windows workloads and Linux workloads. Because at the end of the day, those are the things that are bread and butter, and you are peeling away layers out of that to make your new age solution. And when that happens, you should not be a 0 and 1 transition, right? Like it has to be a slow transition, which reduces the risk of doing it. And when you reduce the risk of doing it, then people adapt it quite a bit. Security and edge scale are really one of the most important things that need to be handled. A security just does not mean just the application security, right? It means hardware security. People should not be able to go in and plug USBs into the device. That is one portion. But at the same time, it's not just about the hardware level security. It's not about like remote attestation, TPMs. It's not just about application level security. It is about people and processes too. Things should be integrated in such a way that like everything right from the time something gets shipped out of a manufacturing entity, all the way to it is deployed and till the end of life of that asset, it should be secure and it should be predictable. And the scale is edge scale, right? Like it is not just about like talking about one single entity or like a few of them. We are talking about tens of thousands. Again, it's a very non-typical Kubernetes environment. It's not a very large cluster with tens of or hundreds of containers or workloads running in it. It's usually small clusters with fewer applications running in them, but like huge number of clusters. Think of 10,000 clusters. It is a reality for us, by the way. This is what we are dealing with day to day today. And there isn't a really great solution for all of these things. And this is where like we are learning, we are helping our users to like bridge that gap. And lastly, time to service is very, very important. It is something to be said about, I am going to ship an asset out to the deployment location, whether it is besides a railway track or on an oil and gas rig or in a dealership. I'm going to be, or in an industrial floor, manufacturing floor. I ship it, people plug it in, and it just works. You do not need to like actually have like 10 other service tickets enabled. And then like people go back and forth for a week plus to like get the service up. If you are going to commission service on 10,000 sites, and if you're only able to do few sites per day, then as you can imagine, by the time you're done with one cycle, you are already obsolete. These things have to happen in a way that it is zero-touch service enablement. So these are the kind of aspects that you have to think about when you are dealing with Edge Kubernetes. And Kubernetes at the edge, again, this is just a summary slide, but like, if you are going to be doing Kubernetes, then you have to have take into account the hardware, you have to take into account the operating system, remote management and visibility and auditing and all of those things, application deployment and management and security. These are the table stakes. If you have solved all of these things, then you can think of layers above it. And that is what like ZEDEDA has been doing. We have invested quite heavily in this aspect in the past 5-6 years. We have enabled a lot of Fortune 500 companies while doing this. But at the end of the day, this layer has to be rock solid before you can think of things above it. Okay. And in this journey, we have enabled a lot of Kubernetes for our customers. Again, it is the same thought process that I showed earlier. And as part of that thought process, what we have done and what we have learned is how to manage these challenges and how to enable Kubernetes at the edge. The first thing that we did is, like I mentioned, industry-leading edge management and orchestration. That is something that is necessary. The second thing that we have realized and what we have understood is the Kubernetes infrastructure at the edge itself is a very big hurdle for a lot of the end users. These are not the folks that have like Kubernetes administrator credentials, of at least not all of them, right? So when you ask them like, hey, here is a runtime, here is an orchestrator, go deploy this in such and such way, I can make it easier for you, all of these things, they still have problems, because now who is going to manage the guest OS that is hosting the runtime? Or if there is no guest OS, who is going to manage the runtime? How are we going to like package it? Who is going to provide support for these things? You have to understand the edge is coming mostly from an OT/IT background, more OT than IT. Then they are not used to this kind of challenges, and they expect these things to be solved. They expect a vertical solution to be presented. So that is one of the things that we did as part of the Kubernetes infrastructure at the edge. Like you can now get a managed service from ZEDEDA where like everything is packaged for you. And like you just point to a few devices and say like, okay, I want to enable Kubernetes there, or a single device and say like, I want to enable a Kubernetes there. Then like the whole, it just happens. And everything, including updates, upgrades, support, all of these things are packaged together. Now, the legacy workloads at the edge is a must. That is what we have observed and like learned. We went in, this is a few years back, like I still remember I went to one of our prospects and I said, hey, here is what we can do. Like this is how you are going to deploy Kubernetes. This is how you are going to deploy containers. This is how you're going to get an outcome. And they kind of slapped me on the wrist and said, okay, hold on. This is great. We know how to do this because we have been doing it in the local data center and the edge. But what we really want is like, how do I take what I already have and then go to where I want to go? And how do I do it by minimizing the risk? Because if I screw this up, then it directly impacts my revenue. Okay. If I screw this up, it directly impacts my career aspirations. There is a human element to all of these things, right? Like no one wants to take an unreasonable risk, especially if it is going to bring down their service and make them the center of attention in a wrong way. So those are the things that we have to deal with. And the other things, and that is something that like we have always included in the product, that like you can actually do legacy workloads and new Kubernetes runtimes. But once you do all of this, you still have the problem of edge scale. The edge scale demands that like you need to have a policy-based fleet level management. It has to be a fleet level management. And it is not a common thing in the Kubernetes environments to say like, hey, you have 10,000 clusters. Forget about 10,000, you have 1,000 clusters. That's not a normal deployment, but that is what we are looking at right now. And how do you manage that? And how do you manage that in a way that it becomes as easy as possible to deploy and operate those edge locations. Now, all of these things are needed. Auditability, visibility, all of these things are needed. But at the end of the day, you also need other services like remote access. How do you access those edge locations for troubleshooting or management? How do you do configuration and security on top of those things when it is not possible? How do you send config files to an edge location when it doesn't have connectivity to your centralized location, right? So all of those kind of things are very, very important. And we at ZEDEDA have tried to address those things. Like, for example, remote access is fully built in. I think it is a very mature and we have a really good story, which is necessary to enable Kubernetes at the edge. But the other things like configuration and security services are equally important. Okay? So it is a full package. If you want to manage edge, it's always a full package. And making Kubernetes, it adds one more layer of complexity, but the reward is worth it. Okay? So this is the last slide I have before we jump into the demo. Again, this is where we are at ZEDEDA. We are offering all the things that I've talked about, and we do that as part of three major products that we have. One is one of them, and the most important one is the Eve operating system. This is an open source operating system living in LF-Edge. It was seeded by ZEDEDA, but we have contributed Eve to LF-Edge almost like 4 years ago or 3.5 years ago, and it's been thriving in that community right now. We also have a SaaS based platform, which a SaaS offering that where our end users, our customers can log in to manage the fleets that are running Eve and everything on top of it. But not only this, it's not just enough these two, right? You need to have that ecosystem. The ecosystem is the most important thing where people can now plug and play different varieties of applications or different architectures, and all of these things are brought into one place. With Eve, with our orchestration capabilities and with the ecosystem, we have that full package that actually helps our end users to deploy and manage Kubernetes at the edge, and also the applications that they want to run on top of the Kubernetes. Yeah. And it is edge, it is scale. So what we have done is we have actually invested heavily into learning and learning of the edge. Our Edge Academy addresses that. Everything from how to use ZEDEDA, but more importantly, what is edge? What are the various different problems that our customers see at the edge? And what we wanted to do is bring in a place where people can come in and learn about things that are happening in different verticals, but also contribute their views in terms of how to do it. If you are interested, please log into help.zededa.com, and you would be able to access almost all of the collateral that is present. And if you are able to sign in, then you would be able to access everything there. And it is free of charge. Anyone can access this site. So I think I covered most of the things that I wanted to cover in terms of what Kubernetes means at the edge and what are the problems. So I'm going to invite John to come in and do the next demo. I'll be on the side and giving some commentary wherever needed. But John, you can take it off from here.
Sure. Thank you, Raghu. If I may share the screen, if you could, yep.
Yep, perfect.
So thank you very much, Raghu. So what I'm going to show today is 3 scenarios where it may be applicable to certain edge deployment situations. The first scenario is where ZEDEDA is orchestrating the edge nodes, and edge nodes is going to be part of a Kubernetes cluster, in this case, a Rafe cluster, and it's going to have worker nodes instances that are running on top of your hardware devices via Eve, and we're also going to have them be able to communicate with the Rafe control plane via the Kubernetes API, and the workers are managed under Eve. The second scenario that we have is the actual Kubernetes controller is going to be running as a VM on the edge itself, where you can see here, in this case, we have a Rancher controller right here. And similar to the first scenario, but everything is now running on your edge locally. And it gives you the opportunity to air gap that environment. So certain customers of ours desire interest in wanting to be able to run things completely disconnected. So they wanted to know, hey, can you orchestrate a Kubernetes cluster and other workloads, not just the Kubernetes cluster, on the edge and be able to orchestrate all that? And the answer is yes. In this type of scenario, what we would do is we would, it's a procedural thing, but once we have your hardwares onboarded to the Z Cloud, we can cut that connection, and this gray boxy here can take over all the operations orchestration via the local operator console. So that's the second situation. And lastly, you don't have Kubernetes altogether. Like Raghu was saying, you may have container workloads that you just want to deploy at scale and want to have zero-touch deployment strategy, where you set it once and you can rinse and repeat. And here we have 3 containerized applications, very simple, dummy applications where some generates data and some, analyzes analyzes that data, and then Grafana will just view those data. So we have 3 containers running again on our edge devices that are being orchestrated by ZEDEDA. What you see here is our ZEDEDA Enterprise login screen. This is the dashboard, the main dashboard. This is also customizable, but the default view gives you a lot of insight on what's going on at your edge deployment. With your edge deployment, it gives you a single pane of glass on what's going on and give you some summary. Of course, as I mentioned, you can customize all this to make it, to display and show what things of interest. What I want to bring your attention to are the edge nodes. You have a couple of edge nodes here. I filtered it out with certain tags with the project, but we have other edge nodes that you can see in a second. That should reload. The idea is that you have many edge nodes that you can orchestrate and be able to organize and be able to manage via various different methods. In this case, we put it into a similar project. And one of the nodes that you saw is this node. And this, obviously, the status gives you a very basic status of what's going on, give you some utilization, also gives you what kind of edge applications are running, some of the volume instances, etc. This is another node that's running the nodes, running the workloads. The 2 Kubernetes clusters are running actually on only 2 edge devices. For this demo environment, our Kubernetes clusters and the work nodes are very small, like 1 gigabyte each. But and that's why we can have everything running on just the 2 edge node devices. But they're running on these edge devices, and the Kubernetes clusters don't care, because we are enabling the control plane to just talk to the worker node through the API. And this is another node that we have that's running the zero-touch, the container-only application without the Kubernetes cluster deployment. And again, we're running it on this node. And if I wanted to rinse and repeat this in certain fashion, I can do so to how many nodes I want, to whatever geographic location that I would like to do.
Just to add one very quick one, like the project concept that John mentioned is a way to group assets into fleets and subfleets. So once you have a project defined, and if you have a couple of 100 devices in there, then you can define the personality of that project in such a way that like every single device in that project behaves behaves in a similar way, except the fact that like you might want to do some variations between each location, because each location might have a different IP addressing scheme, or like they're connected to a different sensors, right? So those are the kind of things that need to be inbuilt into a system so that you can manage your fleets at scale.
Thank you. Awesome. So what I want to just show you next is, now that I've shown you what it looks like on the orchestration layer, what it actually looked like for the consumer. So in this first situation, if you remember going back to the slide, we have the controller outside. So this is the, if you look at the URL, it's the, Rafe controller console. We have a cluster running here running with 2 nodes. This, you could manage your cluster here. And this is the situation where if the customer already has a control plane running in the background and they want to extend this capability onto the edge, you could do so by creating worker nodes on the edge and have it join your cluster. And you just simply push your work load onto certain edge nodes of interest that you're managing with ZEDEDA, and you are just simply adding nodes. In this case, I added 2 nodes, and it gives you some other variable. We got nothing running in here, so there's nothing interesting to see. But the idea is that you are managing your Rafe worker nodes on the edge, where you already have this control plane on the outside. In the next situation where you have everything running inside, you have this air-gapped cluster running. And I did this on purpose in some ways where you can see that, hey, there's something wrong here from this rancher cluster. So you have various different methods of interactions with your workloads on the edge. This UI may be provided to certain other folks that are managing or monitoring just small aspect, just the overall health. And this may be gotten by some API calls or what have you that are monitoring the health of your cluster and seeing what's going on. And you're able to do this even without ZEDEDA, because ZEDEDA is, having the Kubernetes clusters orchestrated on top. So whoever wants to just work with the cluster is agnostic to what's going on, because everything is being orchestrated and being kept underneath the hood. But at the same time, if you wanted to, as the OT person, and wants to say, okay, what's actually happening here? Why is this node going down? Then you can dig in further, and you could use the data to see what's going on and fix the problem at the root. And lastly, this is the URL for the Grafana. If you recall, just really flipping back really quick to the last one, just a zero-touch deployment with 3 containers. Grafana is the one that you actually see what's going on. You have just a couple containers creating content. And if you click on the dashboard, here are some numbers that shows you. Again, if I just am interested in looking at the Grafana portion, I could do so. But underneath the hood, everything's being orchestrated and was effortlessly and seamlessly underneath the hood. And this is what I have for the demo so far. If there's any questions, please let me know in the chats, or we can follow it up.
So, John, like if you can go back to the slides once, please. So I do want to point out one thing here. What we have shown here in terms of Kubernetes clusters being deployed at the edge. Now think of this is one single location here on the slide, right? Like think of them being like 10,000 of these locations or thousands of these locations. Now, you really do not want to go and configure things on Rafe or Rancher or OpenShift or IBM, IAM, all of these things, and then come in, deploy something on a cluster that is thousands of miles away behind LTEs or things like that, right? So what we have done at ZEDEDA is we have partnered with all of these players out there in one. So you can go to Rafe or Rancher or OpenShift or IAM and then say okay, I want to be able to deploy a SUSE Rancher based Kubernetes cluster on the edge. Again, very few people are thinking about K8s at this point, but most of them are thinking in terms of K3s. It is more suited for these smaller hardware devices where you are only talking about a 8 gig of RAM on each of these systems, right? 8 is almost on towards the higher end, 2 to 8 gig of RAM. So now, what the user experience should be is okay, I want a Kubernetes cluster to be running on it, and then there are these 3 different applications that are running, some of them doing some AI inference and others doing some data pipelining. You don't have to go to 10 different places. Through ZEDEDA and through our partnerships that we have done with all these other orchestrators, you can just go and click away and say, or like through API, say that, hey, I want to deploy this on the edge. And like you can do the full lifecycle management throughout. So that is a very big advantage in terms of like how you deploy and how you manage and how you maintain these things throughout its life cycle. But on top of that, like it's also the support factor, right? Like if something is not working, then how do you get support? How do you make sure which layer is not working? How do you know that like it is secure right from silicon all the way to the applications and people and processes, right? So that is the full package that like ZEDEDA has built over the past 3 or 4 years in terms of Kubernetes, and that is why we think like it is we are poised in a right way to like solve this problem. But more importantly, it's not just about ZEDEDA, right? Like if you want to like deploy Kubernetes at the edge, whether it is ZEDEDA or not, you need to think about all of these areas. You need to think about how do I make sure that the end deployment or the field tech does not have to take care of hundreds of these things. But more importantly, they are all predictable. More importantly, the processes that you have set in place are like actually enforced on these edge locations, whether it is at a hardware level, whether it's a Kubernetes level or anywhere else, right? Or the applications on top of it. So that is the thing that like we have done. And in this next slide, what John has shown, if the same scenario occurs, but like if you are on a air-gapped environment, then the only other way for you, I mean, there are other different ways you can solve this, but one of the most popular way is to bring in the orchestrator into that air-gapped environment. That's great. I mean, like you can deploy the smaller versions of it. A lot of people already do that, but now you have to have that person in that air-gapped environment or that skill set available in that air-gapped environment to manage all of that. Not only now you are managing the clusters, but you're also managing the orchestrator. That is not possible if you're talking about tens of thousands of these things, or it is not possible if it is like 100 of these locations. So those are the kind of things that like you have to address. And that is what we have addressed using our configuration services and the local operator console.
Raghu, there was a question by Pete. It says, how do I manage edge workloads via Rancher who calls ZEDEDA? The question is, how does Rancher and ZEDEDA interoperate?
Good question, by the way. So there are different different ways. Like, so for example, if we just look at this slide, it does not matter whether that particular Rancher instance is in an air-gapped environment or it is in a centralized place in a cloud that is managing multiple of these locations. So ZEDEDA today will help you manage the assets in the edge, including configuring the Rancher orchestrator, making sure that like it is registered properly and it also has access, all of these things, right? So when somebody says, I need a SUSE Rancher based Kubernetes cluster at the edge, then like you get everything. Okay. Now, after that, like, how do you manage the applications that are running on top of it? You have two options. Today, like we do recommend like you manage it through Rancher and other orchestrators. But these companies are also like partnering with us a lot more in terms of like, how do I show it in a single pane of glass? How do I like, then the next step would be, how do I actually take these Kubernetes entities and be able to configure it directly through ZEDEDA so that like you can have the uniform experience. So I would say like it is varied. It depends on a user to user. Some of our customers have like large installs of Kubernetes clusters in clouds and data centers, and they use Rancher to manage all of these things, or Rafe to manage all of these things. And then they do not want to have like a second management plane. They don't want to do everything for cloud and Rancher and then like for edge come to ZEDEDA. They would rather do it. But then there are others who want to do everything through ZEDEDA too. Any other questions? I think like we have 10 minutes left, but. Okay, if there are no other questions, first of all, thanks for joining the webinar. Hopefully, it was helpful for all of you who joined. Please do reach out to us if you have any questions on any of the topics that you have talked to. Okay. There was another question actually about how about K3S and K0S. So K3S is the most dominant thing that we see on the edge, especially because K8S is like so heavy. And most of the functionality that is provided by most of the extra functionality that is provided by the K8S is not something that a lot of these edge players are looking at right now. Okay, these are simpler deployments, but at a much larger scale in terms of scales of clusters. We have looked at K0S. I see a lot of traction coming in for K0S2. But if I have to compare all of them, like I would say, like K3S is the one that is the most dominant at this point. Okay. I will wait for another minute for any last questions. Otherwise, it's our pleasure to have the discussion with you all. Hopefully, you have a little better idea about all the pitfalls and also all the constraints that you have to satisfy before going and looking at Kubernetes at the edge. If you have any questions, please reach us out. We are at ZEDEDA.com. Or you can click on the links that are provided on this webinar, and then you can actually talk to us. Okay. Thanks, Leah.